We are from Group 4, and today we would like to present about application of differentiation, which is about related rate. And my name is Ikma Zarif Hakim.
My name is Amma Huraira.
My name is Alif Hakimi.
And my name is Adli Isharil.
Okay, so for introduction, what is differentiations? In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. And also, when do we apply? We find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation. So for application of differentiations, there is related rates, analysis of function 1, increase, decrease, and concavity, analysis of function 2, relative extrema, first and second derivative test, applied maximum and minimum problems, and also Rolle's theorem and mean value theorem for differentiation.
And so now we move to the related rates. And what is related rates? Related rates is problems that include two or more variables and usually change with respect to time. Related rates also help us to find how fast or how slow some quantity change by using the rate of change of the second quantity. So we have seven steps for solution. So first, draw and figure in if applicable. Assign symbol to all variables. Gather information given. Find equation that can be related. Use the chain rule. Differentiate. Differentiate both sides of equation. And lastly, substitute all known values into equation.
So, guys, as we can see here, this is our situation one. So, the question is a water tank in the shape of inverted circular zone has a radius of 20 meter and a height of 40 meter. Water is pumped into the tank at a rate of 80 meter cube per minute. So now the question want us to calculate the rate of water in the tank when the depth of water is 12 meter. If you guys are wondering why we put dv over dt, it is because the question already state that the tank rate is 80 meter cube. So we know it's about volume and volume is V. Now, the question requires us to calculate the rate of water when the depth of water is 12 meter. So, the first thing that we need to do is apply the formula of volume of cone. So, as we can see here, the formula of cone is 1 over 3 pi r square h. If you guys are confused whether you need to differentiate with respect to r or h, you guys can refer back to the question. We want volume in term of height, not r. So, what do we need to do if we want to get rid of the r? We need to find the r. Other than using Pythagoras theorem, we can use the ratio technique, which is r over h. So our r over h is 20 over 40. So first, we can cancel the 0. Then we can take 4 to the other side and it will become 4r equal to 2h. Then eventually we will know that r is h over 2. Now we can substitute the r in the cone formula. So now we will get everything of h. Sorry guys, there is a bit of misunderstanding. Now we can substitute the r in the cone formula. So now we will get everything in term of h, which is pi h cube over 12. Next, we can happily differentiate the volume of the cone with respect to h, and we will get pi h squared over 4. Now we apply the chain rule, which is dv over dh equal to dv over dt times dt over dh. Next, we can substitute our dv over dt into 80 meter cube. Lastly, we we need to make dt over dh as the subject, and we will get pi h squared over 320. Next, we need to rearrange dt over dh into dh over dt because we need to find dh over dt, not dt over dh. After we put all of the numbers into our calculator, and eventually we will get dh over dt equal to 20 over 9 pi meter per minute. That's all guys. Thank you.
Okay, so guys, we move to situation 2. As you can see, the question is a spherical balloon is inflating at the rate of 500 meter cube per second. Find the rate of the surface area when its radius is 20 meter. So, the our step 1 is we need to extract information that has been given. So, in these questions, it gave the speed of incoming wine is 500 meter cube per second. So we must release the formula for the volume. But before releasing the volume formula, we must release the information first. So the volume rate of the sphere is increasing because it is positive, because the wind is comes in. If the wind comes out, he becomes negative. So these questions, he told us uh, to find the rates of increasing. So its area, uh, apa- so find the rates of increasing area. So its area is increasing when the radius is 20 meter. So for the step 2, where you have to apply the formula of volume of the sphere, and which is 4 over 3 pi r cube. And when you need to and then you need to differentiate it to dv over dr. So you will get 4 pi r square when you have done differentiate it. So you have to make a chain rule. But why you have to put dt? It is because dA we can't find it anymore. So when we have do the chain rule, and then we need to sub in the info in the chain rule, then find the area of the sphere. When you have find the area of sphere, when you differentiate it, you will get 8 pi r. So step 3, uh, so you will then you just write the chain rule about the area of sphere. So you just sub into the chain rule. So you will get what you get before the information that you get before. You just sub in it to the chain rule. So you will get 8 pi r equal dA over dt times pi r square over 125. So you will get the answer of dA over dt is equal to 50 meter square per second. So that's it for the situation 2.
So finally, the student should be able to solve questions about related rates. They also should be able to assign symbol to all variables. Other than that, they need to be expert in using chain rule and also differentiate the equation.